Hello everyone, in this video we'll be looking at how to run regression analysis in JASP. This is an overview of the steps that we will carry out. First we have to identify the predictor and outcome variables, and then we check for the model fit, check for the significance of the coefficient, and then check the assumptions. However, for this video I'll stop at the significance of coefficient. Yeah, the discussion about the assumptions for regression analysis will be covered in a different video. Okay, so let's start with the data. Yeah, uh, we have linear regression. Sorry, in the data that I've used for a video on correlation, we click regression and then uh, linear regression, and this is what we have. Yeah, so it's quite simple. As I mentioned before, we need to select a variable for the dependent variable. The dependent variable is where we put our outcome variable. Yeah, so we want to predict the dependent variable using the covariates or using the predictor variable. In this case, I want to predict intention using the variable CCAP or attitude. Yeah, so this is a very simple linear regression analysis, and what we do is now we check for the model summary. Yeah, and then the Anova table. So here in this model summary, we will be looking at the R square value. Yeah, so in this case we look at the this is the baseline model, and then here we have the model that we are testing, H1. So the R square value is 0.359. So what does this mean? This means the model can explain 35.9% of the variances in our dependent variable, or in another word, CCAP or attitude can explain 35.9% of the variances in intention. So that's more than 1/3 of the variances of intention that can be explained by our model. And is the model itself significant? Here we have our Anova table, and we look at the F value 336.697, and the P value is very small. It's less than 0.001. So what does this mean? It means our model is significant in predicting our dependent variable. So it means our model can be used to predict our dependent variable. If the reverse is observed, if the p-value is greater than 0.05, then we have reason to believe that the model cannot be used. The model cannot be used to predict our dependent variable. Okay, and then the third thing that we want to check, yeah, from the third table displayed here is the coefficient. For regression, we make prediction based on a linear relationship, and the formula that we use is y equal a plus bx. Yeah, y is our dependent variable and x is our predictor variable. A is the constant, which is the intercept, the value that crosses the y-axis, and then the B are in this table. So we have unstandardized value and also the standardized value. So if we look at the standardized value, it's 0.6, and we want to know whether this value, which represent the slope of our straight line, is significantly different from 0 or not. If it is significantly different from 0, it means it is a significant predictor. If in fact the slope is 0, it means you cannot use this variable to predict the y values or the dependent variable value. So in this case, what we have is a significant value based on the t-test here. The value of t is 18.349 and p is less than 0.001. So that's a significant value. Yeah, and you may ask, why do we have unstandardized and standardized? Yeah, the importance of the standardized coefficient can be seen if we add another one. Let's add subjective norm into the covariate. Yeah. So now what we have is an increased R value. Now our model is more powerful in explaining the variances of intention. The model itself is still significant. Yeah. And then what we have here is we have CCAP and subjective norm. Now with two predictors, we find that subjective norm is a is a stronger predictor compared to CCAP. Yeah, both are significant, but then when we include subjective norm in the regression model, then the standardized coefficient for subjective norm is greater. So this tells us that subjective norm is a more is a stronger predictor compared to CCAP. And we can also look at the unstandardized values if both CCAP and subjective norms are measured with the same unit of measurement. So for example, if we have subjective norm being measured using a rating scale between 1 to 7 and CCAP was also measured the same way, then it may be possible to compare them directly. However, if subjective norm is measured using a rating scale of 1 to 5, whereas CCAP is measured using a rating scale from 1 to 10, then this value will not be a fair comparison. This value cannot be used to make a fair comparison between the two. We need to look at the standardized value. Yeah, so that's how you read the output from regression. And as I've mentioned earlier, we will not be looking at the assumption that would be in another video. Yeah, so this is just an introduction to regression analysis in JASP, and this should suffice for people who are novice or who are having their first experience in regression. Okay, I'll see you in a different video. Thank you. Bye.